sum of n terms of an AP. So Sn is equal to A1 plus A2 plus A3 plus so on till An. So what is Sn? Sn is the sum of all the n terms of an AP. Also, if we reverse the order and add them, then also it will remain Sn only. So Sn can be written as An plus An minus 1 plus An minus 2 so on till A1. Now we'll add both the Sn, that is we add the first term and the last term, then the second term and the second last term, third term and third last term, and so on. Then adding the same, we will get the sum of the last term and the first term. So we'll make a group of that, and we'll see that there are, because n terms, so there will be n groups of these two pairs. So adding 1 and 2, what we'll get here is Sn plus Sn, that is 2Sn equal to A1 plus An, A2 plus An minus 1, so on till plus An plus An, An plus A1. Now here on adding these two, we are getting 2Sn, because Sn plus Sn is 2Sn, and here we'll use the formula of An. In all this we'll use the formula of An. So first one we are getting A1 plus, An can be written as A1 plus n minus 1 into D. Similarly we'll do the second one, A2 can be written as A1 plus D, and then we have An minus 1, that is also can be written as A1 plus 1 less than n minus 1, that is n minus 2. So A1 plus n minus 2 into D. Same process will follow in the third pair also, that is A3 can be written as A1 plus 2D, and An minus 2 can be written as A1 plus n minus 3D. So plus so on till the last one. Last one is An. An can be written as A1 plus n minus 1 to D, and this A1 will remain as it is. Now we'll add the right terms in each group. So what we'll get here is, to the left side there will be no change, so this will be 2Sn only equal to n into y, because there, as I told you, there will be n groups, n pairs, so n into, now you can see that here sum of each will be, why we have written n, because there will be n pairs like this, and the sum of each is the same, that is 2A1 plus n minus 1. You can check it out. A1 plus A1, that is 2A1 plus n minus 1 to D. Here also A1 plus A1, that is 2A1, and D n minus 2 into D. So that will give you n minus 1 to D. Third pair also A1 plus 2D plus A1 plus n minus 3 to D. So A1 plus A1 is 2A1 plus n minus 3 D plus 2D. We will get n minus 1 to D, and so on to the last one. That also will give us 2A1 plus n minus 1 to D. That means A1 2A1 plus n minus 1 to D is coming n times. So that is why we have to near n. So what we have got is 2Sn equal to n into 2A1 plus n minus 1 into D. Now we'll go further in this one, because we have to obtain the value of Sn. So Sn will be equal to n by 2, 2 into A1 plus n minus 1 to D. So this is the formula to find the sum of n terms of an AP. So what is that formula? Sn equal to n by 2, 2A1 plus n minus 1 into D. Also there is another way of writing this formula. What is that? Sn equal to n by 2. We can break 2A1 as A1 plus A1 and regroup that A1 with n minus 1 to D. So what we will get is this whole, this will become A1 plus n minus 1 to D, and that we know that is equal to An. So also we can write it as Sn equal to n by 2 A1 plus An. So this is the second formula. That is the sum of n terms of an AP is the sum of the first term and the sum of the first term and the last term multiplied by number of terms divided by 2. So this is another formula to find the sum of n terms of an AP, and this is the first one which we have obtained. So both the formulas can be used as per the requirement.